Okay, in this lesson we're going to do something called the pigeonhole principle. And if you don't overthink this and make it more complicated than what it is, it shouldn't be too hard. So imagine we have n pigeons and they're going to fly into n minus 1 pigeonholes, so one less. Then we know there'll be at least one pigeonhole with 2 pigeons in it. So let's think here, we've got say 4 pigeonholes. The first pigeon goes here, second, third, fourth. The 5th one must double up one of those boxes. So if we've got one more pigeon than pigeonholes, then someone has to share. Now that doesn't mean that will happen. They might all decide to fly into this one because it's nicer. But worst case scenario is they all go into one separate each, and then the last pigeon has to choose a pigeonhole to pair up inside. So now we can generalise that a little bit. This seems a bit weird, but when we do it with numbers, you see it's not too bad. If we've got n pigeons and they're going into k pigeonholes, n is bigger than k, then there is at least one pigeonhole with at least n over k pigeons in it. So for example, if we go to this case here, again where we've got 4 pigeons, 4 pigeonholes, and maybe I'll take in 10 pigeons. Okay, what could happen? So we go pigeon 1, 2, 3, 4, 5, 6, 7, 8. Right. So maybe the 9th pigeon goes here and the 10th goes here. So we'll have at least 3 in one of the pigeonholes. Okay, we could have more, but we'll have at least 3. What does that mean? I had 4 pigeonholes and 10 pigeons. So what will happen, since 4 times 2 is 8 with 2 remainder, we've got these extra 2 pigeons that will make the pigeon go in and create an extra one in the pigeonhole. And so we're just looking at basically divisibility. Anyway, that seems crazy. So let me show you an example and you'll see it's not too bad. Okay, we've got 70 guests. They're like our pigeons. And we've got 23 tables. We want to prove there must be at least one table with at least 4 guests. So what we're thinking of in our worst case scenario for our 70 guests, for each of the 23 tables, 3 will go to each table. Picture it, 3 go to the first, 3 go to the second. And what's 23 times 3? 69. So we have 1 left over. So what we can say is, because we had a remainder, this 3 here means that at least one table has 4 people on it. Why? In a test, you'll write the pigeonhole principle, you'll write it in words, but I'll let you abbreviate it for your working today. How many guests must there be to guarantee at least one of the tables has at least 11 guests? So what we want to do is we want to put 10 on every table. Notice I'm always going that at least 11, I dropped it down 1. At least 4, I dropped it down 1. Okay, so I'm sending 10 to every table, so that's 230, and adding an extra person, because that extra person will have to join a table of 10, making it a table of 11. So what's that? 231. We need 231 guests to make sure we have at least 11 guests. Okay. All right. A suburb has 15 apartment blocks, and a person knows 200 people from these blocks. So that's like your total. So we might as well just write 200 equals. Explain why they must know at least 14 people from at least one block. Now remember that at least always round it down to 13. So what is 15 apartment blocks times 13 people? Hopefully it will be less than 200. 195. So I get a remainder of 5. Therefore, this is true, must know at least 14 people from at least one of those pigeonholes, one of those boxes. 1 block. Okay, so hopefully you're seeing the pattern. How many people from these blocks must they know? In order to know at least 25 people from at least one block. Okay, so we're going to go 24 times 15 blocks, add 1, so we get that extra person, so we know at least 25 people from one of those blocks. 361. Okay, so let's have a look at example 3. I find the wording a little bit tricky in this one. So Bill has 30 hats, and every day he chooses a hat at random to wear. So if we think of that, there's 30 times 7, 210 possible combinations. So for example, there's the blue hat on Monday, the blue hat on Tuesday, the blue hat, and then the red hat on Monday. So I've done the 30 different hats times the 7 different days, 210 possible combos. And what we want to do is see how many days in a row are needed to guarantee that at least one day of the week he's worn the same combination. So for example, we want to repeat the blue hat on Monday on at least 6 occasions, okay? So let's have a think about that one. We've got 210 possibilities. And we want at least 5 of those, plus 1 more, okay, so to make at least 6 on an occasion. So how do we write that out, thinking about the pigeonhole principle? So imagine he runs through the 210 combinations 5 times, not repeating any of them. 1 more will mean that he has to have a repeat. And now we've got our minimum number of days, there it is, to make sure that he's repeated something on 6 occasions. Let's grab my calculator, and we've got 1,051 successive days. A little bit tricky, that one, I think. Okay, example 4. How many odd numbers less than 20 must be chosen to guarantee that 2 of the chosen numbers add to 20? Well, to start, I'm just going to list out the odd numbers. Don't really know what's going on here. Let's see if this will help us by starting with what do we actually know. Okay, so there are my odd numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them. And we want to guarantee that 2 of the chosen numbers add to 20. Well, let's have a think about all the different ways we could do that. So our pairs to make 20 would be 1 and 19, 3 and 17, 5 and 15, 7 and 13, and finally, 11 and 9. So that's 1, 2, 3, 4, 5 pairs. So once I've chosen one of these numbers, if I choose the other one, then I have the sum of 20. So let's consider the worst possible scenario. So imagine we choose all of these ones here. Then we definitely don't have a sum of 20. But if I choose one more, then in that pair I will have a sum of 20. So we need to choose at least 6 to ensure we have that sum of 20. So just pause and have a think about that. Obviously I choose the worst scenario first. I could have chosen the smallest 5 or the highest 5, but once we get a pair, one from the lowest and one from the highest, then we would get that sum of 20. So what did I do? I put them in pairs. chose 1 from each pair. So that's 5. Add 1 more, and I definitely would have my sum of 20.